So this question gives you information about 3 different linear relationships. And the question part is circle relationships that have the same rate of change. Justify your answer. Include information about all 3. So before we take it up, who thinks they know which ones are the same rate of change? Vanessa, which ones did you get?
1 and 3.
1 and 3. Did anyone get something different? Reese?
1 and 2.
1 and 2. Anyone else get something different?
I got all 3.
All 3. Anyone else get something different?
Oh, 1 and 3.
You got 1 and 3? Okay, so we've got 1 and 3, 1 and 2, and all 3.
All 3. All 3.
Let's see. Check her out. Okay, so for the first one, if I'm only interested in the rate of change, I would do rise over run. You guys good with that? It's positive sloping. The rise is 5. The run is 10. Correct? Why is the run not negative 10? It's rising, and if you put a negative, it's always with the rise, right? And with the run. This is from negative 10 to 0 is 10. And from 0 to 5 is 5, and it's got a positive slope for sure. It's rising to the right. So does 5 over 10 reduce? 1 over 2, good. 5/10 is a half, awesome. All right, the second one, as I was walking around, most people decided to get y by itself here.
Can you technically turn 1/2 into 0.5, or is it?
Yes, you could do that as well. Yeah. So create 2 0 pairs. 6y is equal to negative 3x minus 1. So I can already tell that this one's going to have a negative slope. So they can't be the same. So all 3 is out. Because here we've got negative 3 6x minus 1 6. So our y-intercept would be pretty hard to plot, but this is what we're focused on, is our slope. Can that be reduced? Negative 3 over 6 can be reduced to negative 1/2. Good. So far, neither one's the same. We've got positive 1/2 and negative 1/2 for our slopes. Okay? So the third one's probably going to be the tiebreaker here. Chart. To get from negative 3 to negative 2, I go up 1, up 1, up 1. And on this side, up 2, up 2. Remember, this is our rise side, change in y. This is our run. So the rise is 1 when the run is 2. So that means 1 and 3. 1 and 3 both have a rate of change of 1/2. So I'd circle 1 and 3. Let's make sure you've answered it. Circle the relationships that have the same rate of change. Justify your answer. So, therefore, relationships 1 and 3 both have a rate of change of 1/2. Okay, and we've showed all our justification because we've shown the math for each relationship. Okay? All right, we're going to do a mind run that's going to start us off for our topic today, which is parallel and perpendicular slopes. So for today's lesson, you need pencil, eraser, ruler, calculator perhaps. All right. So the graph shows two line segments that are perpendicular. Determine the slope of each line segment. Okay, so you should be able to, I'm just going to pause it, find the slope of each. So the slope of AB. Make a right triangle there. So I can tell that AB is a negative slope. So my rise would be -7. And my run is 6. So that would be my slope. It doesn't reduce. For CV, holy, I made a mistake. My bad. Oh, sorry guys. Can you erase CD? I'll just draw another line segment up here. We'll even start at C. I'm going to end somewhere else. There's my correct D. I'll make it with a red line. There we go. There's the correct D. So it's the end point is at 0, -1 there. So we know for CD that it has a positive slope. I'm going to make a right triangle. So with my new spot for D, rise is +6, and the run is 7. And if you were to take your ruler and have CD hit AB, it should look like it hits it at a 90-degree angle. So let me get a dotted line here. Dotted here. Red. So if you were to extend that, line, dotted, red. It should look like this, they meet at a 90-degree angle, okay? And lines that meet at a 90-degree angle is said to be perpendicular. So this word, how many people have heard that word before, perpendicular? So it means meets at 90 degrees, okay? So if you look at these two slopes, what do you notice about the slopes of lines or line segments that are perpendicular? How would you recognize them? Yep. They're opposite. So first of all, one has to be positive and one has to be negative. Okay. And then what's the other thing that's different about them?
The numbers are
Flipped. Okay. So perpendicular slopes have opposite signs. And the rise and run are flipped. And there's a special math term for that. You can write that out, that's fine, but there's a special math term for that. Does anyone know what the special math term for opposite signs and flipped is? They're called negative reciprocals. So reciprocal is the math word for flipped, upside down, and then negative means opposite sign. Okay, so if you got a negative, the other one's positive. If you've got a positive, the other one's negative. Okay, so they're said to be negative reciprocals of each other. So perpendicular slopes have opposite signs, and the rise and run are flipped. Okay. So now that we know this, you're going to check and make sure that theory works with the next two lines there. So find the slope of each one, and once you figure out the slope of each line, they should be negative reciprocals or opposite signs and rise and run flipped. Okay, it doesn't matter which I'm going to call this one line 1. Okay, so I have to find a corner. And another corner. A negative sloping line. So the way I made my right triangle, my rise is -4 and my run is 6. But I would always see if I could reduce that. I can, they're both even, so I can divide top and bottom by 2. So I get the slope is -2/3. How many people got -2/3 for the slope of the red one? So if they are perpendicular, how could you take this slope and predict what the slope of this one would be? Amelia? Flip them? So and make it positive. Perfect. They have to be opposite signs. Okay, so this is our prediction. And then we're going to actually draw a right triangle and see if that's true. So here's a corner for me. Here's a corner for me. Positive slope, 3 for the rise, 2 for the run. That is in fact what I get. And that means that this is a 90-degree angle here. We mean at 90 degrees, perpendicular. So if they're not that exact thing, if they're not negative reciprocals of each other, if they're not opposite sides and flipped, then they're not perpendicular. It may look pretty close, but they're not. Okay? All right, so we're going to start out, how are the slopes? We already said that, so we're good. All right, we're going to go on then with our lesson 28 on perpendicular, really perpendicular. Oh, Mr. Jago.
Good morning.
You're welcome. You're welcome. You're welcome. Okay, so we already talked about previously that parallel lines have the same slope, so that's important to know. parallel lines have the same slope, okay, like railway tracks have exactly the same slope. And we just learned that perpendicular lines not only meet at right angles, but their slopes are negative reciprocals, which you now know what that means. Perpendicular slopes are negative reciprocals. So classify each pair of lines as parallel, perpendicular, or neither. Okay? So you've got two lines here. Line 1 and line 2, we could call them. Line 1 is in that lovely y equals mx plus b form. So we already know the slope of it. Does everyone agree? I know the slope. I can also draw it. They give me a grid, so I might as well draw it, practice drawing it. So I know the initial value is -1 for the y-intercept from yesterday, and I know the slope is 2/5, which is my rise over my run. So from the y-intercept, I'm going to rise up to and over 5. Reverse it. Draw my line in. Here's my end, and this is line 1 for me. Line 2 is going to take some more work though. I have to use what I learned yesterday about switching forms. So adding 5y to both sides so that I have a 0 pair here. So now there's 2x plus 10 on the left side and 5y on the right side. So I just want y equals, not 5y equals. So I'm going to divide every single term by 5. I want the slope to jump out in front of x. And then 10 divided by 5 works out to be 2. And if I just switch sides, I've got it in the form y equals mx plus b now. So now for the second one, I know that the y-intercept is +2. And I know that the slope is 2 over 5, which is exactly the same as it was for the first one. So that should mean parallel, right? Same slope. Same slope means parallel. You can draw it in. So from 2, I'm going to rise up 2 and go over 5. And when I draw it in, it should look parallel because it has the same slope. So here's line 2. So classify each pair of lines as parallel, perpendicular, or neither. So therefore, these lines are parallel. And I would add on, especially if I was on an assignment, because they have the same slope. Okay, it's an easy sentence to write. They're parallel because they have the same slopes. So the second question is a similar type of question. You're still deciding whether the lines are going to be parallel, perpendicular, or neither. One of them's easy to, it's already given in y equals mx plus b, the other one's not. So I'll give you some time to try that one. See what we got here. Most people have drawn the first one from what I can see from the front. There's my first line. The y-intercept is -4. And the slope is 3, which is my rise over my run. Which means my run is that invisible 1. Okay, so from my initial value, I'm going to rise up 3, run over 1, positive slope, drawing my line, arrows on the ends, and this is my line 1. Okay, so line 2 takes some more work. Because it's starting off with a positive number in front of the y, personally I would move the other 2 terms, so I would subtract x on both sides and add 15 to both sides. So that all you've got left on the left side is 3y, and on the right side you now have negative x plus 15. Divide every single thing by 3. There's a 1 between the negative sign and the x, so the y equals negative 1/3 x plus 5. Do you rearrange it properly? Yes? So looking at these slopes, 3 and negative 1/3, perpendicular, rise and run are opposite and they're opposite signs, right? Okay, so when I draw this, I'm expecting it to look like it needs at 90 degrees. Okay? So I'm going to plot my y-intercept, which is 5. And then my rise over run. Is down 1, right 3. Negative sloping. Different color. Okay, so this is my line 2. Okay, so then I need my therefore statement. Therefore, line 1 and line 2 are perpendicular. And then your because can be because the slopes are negative reciprocals. That's restating perpendicular again. So it's not your, it doesn't have anything to do with the, well, it does have to do with the slopes, but it's restating perpendicular twice. So because the slopes are negative reciprocals, or you can say because the slopes have opposite signs in their rise or run or flip. Okay? It just takes more words to say that. So this word here says opposite signs and rises and runs flipped in just 2 words, negative reciprocal. But one thing, when Amelia said there meet at a right angle, it's always good to show that you know something's perpendicular by adding that right angle in. Okay? Teachers like to see that, QA likes to see that, because it says we know what perpendicular means. All right, good. So the next one, still the same question, parallel, perpendicular, or neither. Okay, I'll give you some time. Give me my line 1, being negative 3. And my slope being 1/2. Destiny, if you want the, can I get up here? Will you sign in? Awesome. There's line 1, line 2. Anyone want to say what their first step for line 2 would be? Vanessa. Line 2. So you get? Perfect. So y is 2x minus 1. Pretty good. So in that case, this is our line 2. Our y-intercept would be -1. And our slope would be 2, which is our rise over our run. So from -1, we're going to rise 2, run over 1. Reverse it. Draw in our line. Okay, they don't look perpendicular. Why are they not perpendicular? Vanessa. They're both positive, good. So they may have the rise and run flipped upside down, but they're not opposite signs. Does everyone see that? Okay, so these, therefore the lines are neither parallel nor perpendicular. Okay, so it's tempting when you see the rise and run flipped upside down to think they're automatically perpendicular, but they have to have opposite signs as well. Okay? So remember that. And you can see it on here, they don't look anywhere close to a 90-degree angle when you draw them on the graph. Okay. All right, good. All right. Next question. Draw a line segment that is parallel to the line segment with endpoints A1, 2, and B5, -1, and a line segment perpendicular to it. Okay, so if that were your question, this has been on EQAO before, very similar. Does anyone have a plan for how they would do it? Or at least how you'd start it? Carter? Plot the points. Okay, so we have to remember then that the first is a x and the second is a y. So 1, 2 is here. That's my A. And B is 5, -1. So from 0, 1, 2, 3, 4, 5, -1. And anytime I'm plotting points, I always double check them. So before I draw in my line, I'm going to double check 1, 2 is right, and 5, -1 is right, because it's really easy to make a little mistake when you're plotting the points, and then your slopes won't turn out right. Okay? So double check, I know they're right, so I'm going to join them with my ruler. All right, so step 1. Now I have to draw a line segment that's parallel with it. Any ideas how I could do that? No.
You find the slope.
Perfect.
The negative reciprocal.
Parallel first. Gotcha.
Well, you could find the slope and then make a line like right next to it. You say the same rate?
The same rate of change. Good. Okay, so does everyone agree my slope is down 3 over 4? So if I'm looking at the slope of AB, I would do rise over run. Everyone see that it's a negative sloping? Okay, so it doesn't matter, this is one thing I want you to know for a line segment, it doesn't matter where I start, this is my formula for making it parallel. I'm going to use the same slope. So I can pick a corner and start anywhere. I can start right here. As long as I go down 3 and right 4 to put my next point. Okay, anywhere you start, as long as you go down 3 and right 4, you're going to have a line segment that's parallel. Does everyone see that? Okay, so I'm going to label it. C and D. So down 3, right 4, those should be parallel. So I have to say that sometimes, draw a line segment that is parallel. So therefore CD is parallel to AB. Now I have to draw one that's perpendicular. Okay, Johan, so how do I draw one that's perpendicular?
Find the negative reciprocal at either point C or D and just do the line.
Okay, so if it's perpendicular to this slope, then it's going to have a slope that is positive. Does everyone agree? And the rise and run are flipped upside down, so the slope would be positive 4/3. And again, I can start anywhere I want as long as I apply that slope to get my second point. Okay, so pick somewhere to start, and you're going to rise up 4 and run over 3 to get your next endpoint. Start anywhere you want, as long as you don't run off the grid. Okay, so I'm going to start here, rise up, 1, 2, 3, 4, run to the right 3, and that should be perpendicular. And I'll call that, I've used A, B, C, and D, so E and F. So therefore, EF is perpendicular to AB. Okay? Any questions about that? Find the slope. Okay. All right, on to our next question. If a line is perpendicular to that line, what would its slope be? This is often in your QA02, although they give you 4 choices for the slope. Okay, instead here we're just going to find it out instead of having a multiple choice. So if a line's perpendicular to that one, what would its slope be? Does anyone have a plan on how we could do this question? William?
Solve the equation.
So get y by itself so we know the slope. And then once I know the slope of this line, what am I going to do for a perpendicular? Flip it and change the sign, right? Opposite sign. Perfect. Okay, that's the plan. Go ahead and try it out. Okay, so there's my switching it into y equals mx plus b. How many people got that for that? Okay, so that means the slope of this line is 5/3. So if it was perpendicular, so we can do our therefore statement right now. Therefore, a perpendicular line should have a slope of m equals, all right, so this slope's positive, Everyone good that perpendicular has to be negative? Yep. What is the whole answer?
-3/5.
Yes. And that would be the full answer there. That's what you need to show, full marks. Okay, you got the slope of this one and identified it, and realized perpendicular should be opposite sign and rise and run flip. Okay? All right, similar type of question for number 4. If a line is parallel to that line, what would its slope be? So again, parallel means same slope, exactly the same slope. So the plan should be the same. Figure out the slope of the first one by getting y by itself. But instead of changing the slope, you want it to be the same. Okay, so to get into y equals mx plus b, I would add 9y because the coefficient in front of y is negative. So both sides of the equal sign. And this follows both sides. Then divide every term by 9. So I get y equals 2/9 x, which I can't reduce, but I would check if I could, but I can't, plus 2. Which means I now know the slope is 2/9. One thing I didn't talk about when we were taking up the assignment is some people put slope as like a half x. Slope is just the number in front of x. It doesn't have an x in it. Okay? So when you're talking about slope, remember it's just a number. So here you're identifying it. And then your statement is then it's going to be therefore a parallel line would have a slope of m equals 2/9. It would be the same slope. Okay? So just in that statement, you've shown that you know parallel lines have the exact same slope. All right, and then question 5. This one's easier because it's already in y equals mx plus b. If a line is perpendicular to that line, what would its slope be? So you should just have to write out the slope of this one and then your statement. Okay, so I've seen some people like just doing an arrow which slope is -5, and then I've seen people adding over 1. Smart. Once you know that, you just need your statement. You can ask somebody for their statement in a second. Who thinks they got a statement for this one? Amelia?
Perpendicular line would have a slope of m equals 1/5.
A perpendicular line would have a slope of m equals 1/5. Perfect. Okay, so flipped opposite sign. Yep. This is negative, so they have to be, if they're perpendicular, if this one's negative, this one has to be positive. They have to have opposite signs. Okay. Good. All right. Almost break. We got a minute. So you can start this one, but I'll just tell you when. So number 6. If a line is parallel to this one, what would its slope be? So you guys were starting this before the break. I would probably, because the number in front of y is positive 3, subtract 8x on both sides of the equals, and subtract 24 on both sides of the equals. It would be 2 0 pairs. 3y on the left side, and negative 8x minus 24 on the right side. Still, to get y by itself, divide every single term by 3. Make the slope jump out in front. Show that you know the slope. And then make your statement. Parallel means same slope. So therefore, a parallel line would have a slope of m equals negative 8 over 3. Okay? And then number 7. What is the slope of a line perpendicular to a line that has an x-intercept of 4 and a y-intercept of negative 5? So it gives you a place to graph in order to find the slope of the initial line. So once you're done 6, move on to 7. You should be able to plot the x and y intercepts, figure out the slope. Yes, I do. Okay, so what is the slope of a line perpendicular to a line that has an x-intercept of 4? So yesterday we learned what that means. So on the x-axis there'd be a point at 4 and a y-intercept of negative 5. So on the y-axis there'd be a point at negative 5. So I should be able to find the slope out. So positive, I can tell that by looking at the line. And it's got a rise of 5 and a run of 4. So the slope of this line is 5 over 4. So what would be a good statement to say what the slope of a line perpendicular would be? Reese?
Therefore, a perpendicular line would have a slope of negative 4 over 5.
Perfect. So negative 4 over 5, perfect. Flipped with the opposite sign. Very good. So I showed my work. I found the slope of this one, put it over here, and then I made my statement. Done. All right, and that is our lesson. So I'll hand out the practice.